Okay, I just wanted to make a video for the application and extension portion of this week's packet for 3.1 lines and angles. The first two, I don't think you guys should have too much of a problem. Just remember interior, exterior, exterior. You should be okay with those two. All right, these next ones though we'll take a look at together. So number 3, we're going to graph these lines. And so just a refresher from geometry, we're going to start at the y-intercepts. These are the y-intercepts. And the number, right, the m value is your slope, right? And so if there isn't a number right there, right, we don't see one, but we do know that is a 1 in front, right? That's a 1x. We just don't need to write that. So for both of these lines, they have a slope of 1, or we could also say 1 over 1. Okay, so let's go ahead and plot these out. Remember, we start at the y-intercepts, so let's plot the first one out. We start at -1, and then we're going to go up 1 over 1, up 1 over 1, up 1 over 1, and we'll plot that line out. And let's see, let's do the other one too. The next one, we're starting at the y-intercept of 2, and again, going up 1 over 1. We can also say we're going back 1, down 1, which is negative, negative, which again makes a positive fraction. So back 1, down 1 again. All right, so I'm going to go ahead and use my ruler here and connect these lines. Okay, that looks, it's not really perfect, but it's okay. Let's see if I can do this next one a little bit better. Okay, we'll try it. Okay, there we go. Again, not totally perfect, but it looks pretty good. All right, so what type of relationship is there between the two lines? They certainly look parallel, right? Okay, and how can, or it says number 5 says prove your answer to number 4. So even though they look parallel, we can actually prove it by just saying that they have the same slope. Okay, because if two lines have the same slope, they are parallel. Okay, all right, number 6. Now we're going to graph the equation of the line y is equal to 1. This one sometimes students struggle with. Remember, a lot of times people will get the first point, they go, okay, y, on the y-axis, here's 1. But then sometimes I get students drawing a vertical line, horizontal line. You're just going to remember that y is always equal to 1. So at 0, 1, it's right at 0 on the x-axis, it's 1. At -3 on the x-axis, the y is 1. +4, it's 1. So you write a few more points out, and then you can see that it does make a vertical line, or sorry, a horizontal line. So I'm going to go ahead and plot that point out here real quick. There we go. Okay, let's get rid of that. So let's see. Number 7, what line is the transversal in the graph? Okay, well that would be this line here, right? This is the transversal. Okay, and so what line would that would be? It would be y is equal to 1. All right, let's see here. Let's label all the angles. So it doesn't matter how we label these. I'm just going to go ahead and go 1, 2, 3, 4, let's see, 5, 6, 7, and 8. Okay, there's all my angles. And so now we can go ahead and start listing some angle pairs. So I'm going to leave you guys up to number 9. What pairs of angles are alternate interior angles? Okay, I'll let you guys do that one. Using a protractor. So you guys Might not have a protractor. If you do, you could follow along. I'm going to pull mine up here. So this probably doesn't look exactly like your protractor, but it's essentially the same thing. So I'm going to go ahead and move this right here. And there we go. It looks like this angle is about 44, 45 degrees. So I'm going to go ahead and say that this is 45. Oops. 45 degrees. I think I have to take this off. So I'll take this off. I got 45 degrees for angle 3. The measure of angle 3 was 45. And so what would be the other pair, or the other angle of the pair of alternate? So 3 and, pause the video if you need to, 3 and 5. Okay, so let me go ahead and pull up and label, or sorry, measure angle 5. I'm just going to move this over here. Boom. And move this one to right there. So it looks a little bit off. Okay, so it's not exactly perfect, but again, neither are my lines. This one also looks right to be about 45 degrees. So let's see, so angle 5, I'm going to take this down. So it looks like also the measure of angle 5 is about 45 degrees. Okay, so now it says number 11, based on your evidence of numbers 9 and 10, what do you think might be true about alternate interior angles when the transversal crosses parallel lines? It says test it out with another pair of alternate interior angles. So if we add 3 and 5, that is one set. How about 4 and 6? So we can go ahead and test that out. Let's see. So I will go ahead and do this one for you. Number 6 is, looks like about 135. Let's check number 4. Here we go. Oop, I'm going the wrong way. Okay. Okay, again, looks like 4 and 6 are pretty close to the same measure. So what might be true about alternate interior angles? All right, number 12. What pairs of angles are same side interior angles? So let's see, same side interior angles. Okay, again, this is the interior, so same side would be like 4 and 5 or 3 and 6. So we just did the measure of 4, right? Oops. So what pair of angles? So how about we just go with 4 and angle 5. You guys could mention the other pair. And then using a protractor, measure one pair of same side interior angles. Well, we just did that for angle 4, right? And the measure of angle 4 was about 135. And we already know from up here, number 10, that the measure of angle 5 is equal to 45. So now that we see that, based on our evidence of 12 and 13, what do you think might be true about same side interior angles when the transversal crosses parallel lines? So is there anything significant about measures 35 and 45? Might want to play around with those two numbers, see what they come up with, and see if you can make a prediction about something that we could say is true about same side interior angles. All right, hopefully this video was helpful. Let me know if you need more help. Come see me on our Google Meet.